In this video, I am going to be using the LogoPress 3 Gold Certified add-in to SOLIDWORKS to create a progressive strip assembly and tool assembly. First, I will need to open up a file. I'm going to open up the dimple tab Parasolid file. My computer is set up to run import diagnostics. I'm just going to select no. And then I'm going to change the display style to shade it with edges so we can see the edges of the faces. The file that we opened was to use SOLIDWORKS. It could be any part file that can be opened in SOLIDWORKS and saved as a SOLIDWORKS part file. That being the case, I will need to save this part file because technically it's not a part file until it is saved. I'm just going to save it right into that same folder. We can now begin to create the stations of the strip. There are only 3 stations, working stations. There's going to be the flat blank, the station where we are forming this dimple, and then the station where we are bending this tab down. With LogoPress, you always are working with the finished part and then working backwards towards the flat blank. It's just easier to deconstruct the part than it is to construct it in the forward progressions. First, I am going to insert a LogoPress feature called a station mark. So I'm going to select the Insert a Station Mark icon. And you can see the feature in the tree here, 010 station mark. You do not have to rename these, but I suggest that you do so you can tell what these stations are. This is going to be 010 bend tab. Since we are working our way backwards, the station before this, which is where we are forming this dimple, this leg is not bent yet. So I'm going to unbend this tab. I'm going to use a LogoPress function called unbending by steps. The first thing it's asking you to do, you can tell because this box is highlighted blue, is it says select the round faces to unbend near the fixed face side. You can select either the inside or outside radius of the bend. And you want to select near the edge that you want to stay stationary. That means that if I select near this edge, the main portion of the part is going to flip up. I'm going to select near this edge right here, and then this leg, the leg is going to flip up. You can tell that the fixed edge is purple and is being populated into this box right here. Down here we can set our K factor, quarter, third, 2/5, half. I'm going to be using a German standard called DIN 6935. That will automatically calculate the K factor for us, the neutral fiber. I'll just click OK, and the leg is unbent. Unbending by steps is a function that will reopen itself because it's pinned in place. You can see that right here. So when you're done, I just cancel out, and there's our unbending feature in the tree. I will then insert another station mark and rename this one, and you can see the next station mark is automatically labeled 020, but I will rename the second half of the name to be dimple, 020 dimple. Well, the station before forming this dimple, that dimple is not there yet. So I am going to remove that. I am going to use a SOLIDWORKS surfacing tool called Delete Face. I am going to set it to delete and patch and select the faces that I want to delete. That is going to be the two faces on the top and the two faces on the opposite side of the part. I'll select OK, and it deletes and patches those faces. I'll insert LogoPress 3 station mark and rename that station mark to flat blank. So we have all three of our station marks in here. Now any openings that are being pierced at die level, meaning not at a different level other than die level, like in the bottom of a emboss or after a step is formed, they can be left in the flat blank. LogoPress 3 will automatically manage those holes once we get into the strip assembly. Right now I'm going to save this part. And the next step is to prepare the part for the strip assembly. So I'm going to select this icon, part preparation before strip starting. It's always going to ask you if you want to rebuild the reference part. I always select yes to make sure that the station marks, everything is updated in that part. Next, you can see it created a new part file, which we refer to as the annex part. The original part that we had open we referred to as the reference part. So in the annex part, you can tell it's the annex part because it has _for_strip added to the name. The reference part was only called dimple tab. You can see that there is just a series of configurations in the annex part. It also puts you into the part preparation function. So the first thing it's asking for is select the reference face. So I am going to select the reference face is the die plane face. What face is at die level? Right now I cannot tell whether it's this face or this face. There are two ways that we can determine that. One way is to change our configuration of the part using this pull down list. And then I can rotate the part. Then before making this selection, we have to make sure that we change the configuration back to the flat blanks configuration. Another way to determine what side is at the die level is to use this function, show hide imported bodies. I am going to select the bodies I want to make visible, rotate the part, and then come back up here and hide the bodies. Now I can select my die plane face. You can see focus moved from this box down to this box. It says select the point that you want as a part origin. You can select a vertex, or you can select a diameter or an arc, and then it goes to the center of that diameter arc. But we are going to select a linear edge, this linear edge, and it goes, as you can see, to the midpoint of that linear edge. These selections are just helping LogoPress determine how to place this part in the strip assembly. So I'm going to select OK. And LogoPress finishes creating the strip starting folder. I'm going to save the part. Next, we can create the strip assembly. So while in the annex part, remember that's the part that has the strip starting folder, I am going to select Create, Edit a Strip Layout. At this point, it will open the Save As dialog box. I am going to save it into my strip assembly folder, and I will give it a file name. I like to call all my strip assemblies just that, strip assembly. Because what determines or makes each strip assembly unique is the project name. We can enter a prefix or a suffix. This in the workplace would be your job number, tool number, quote number. I'm just going to add a prefix called 444 with a dash behind it. And you can see it automatically added that to the file name. And I add that dash or a space or underscore so I know where that project name ends. I'm going to make sure that the strip feeding direction is checked so it'll feed right to left. And then lastly, I'm going to go into the configuration at station portion. It opens up a dialog box, and this is where we can rough in our strip stations. You can see at minimum it gives you a station per configuration of the annex part. I'm going to add 2 idle stations after the dimple station and the bend tab station. To do this, I just select the station and select the add an instance of the selected station icon, and I'll just select it twice, and you can see it added 2 idle stations. Then I'll select the bend tab station and add 2 idles after that. Once I have that done, I can click OK. Now this is just roughing out the strip. We can always add or remove stations later once we're in the strip assembly. I'll click OK. Again, make sure that your feeding direction is checked right to left because this cannot be changed after the strip assembly is created. If it is done incorrectly, you will have to close that strip assembly and then recreate it from the annex part again. So I'll just select Save. And it is creating the strip assembly. And the first thing I'd like to do once the strip assembly is created is to select Save and save this strip. You do not have to exit a LogoPress function when selecting Save because LogoPress automatically closes it down and reopens it for us. By default, LogoPress will give us 1x stock thickness scrap in the front and in the back, and then it'll give us 2x stock thickness scrap in between the parts in the progression. First thing I'm going to do is I'm going to rotate the part 90 degrees so that the tab is facing the front of the strip. I can do that with this value right here, angular part position. I'm going to change that to 90 degrees. And you get a preview of this in the first 2 stations of the strip assembly. That change is not made yet, we just get the preview of it. Next, I'm going to scroll down to the strip parameter section, and I have 2 values here. I have our space between the parts, and then also our step, pitch, or progression value. First, I'm going to change the space between the parts. I'm going to change that to 1/4 inch. You can see that change has been updated in the preview, and now I can toggle up to the step value by using this icon. Switch between setting the step or the space between the parts. I click on it, and now I can change this value. So I'm going to round this to a nice even number of 3.5 inches. Then you can see the space between the parts value has now updated. I'm also going to change this value down here, fixed value from the top of the strip. The fixed value from the bottom of the strip is grayed out because it is now set to balanced, meaning you're going to have equal scrap in the front and in the back. So I will just change this value to 0.150. Once this is changed, then our strip width value has updated. And now I'm going to change this to a nice even number of 4.50. Once I hit enter, you can see that this value is pinned in place, meaning that LogoPress will not change this value. We can change it, but LogoPress won't change it if I change some of these other values. I can always unpin it by clicking on this icon or clicking and pinning it in place again. I'm going to leave it pinned. Now we have a bunch of values or a bunch of changes being made to the strip that are being previewed. Oh, there's one more thing we need to change. The X part position. I'm going to change that. Our progression is 3.5 inches, so I'm going to make that half of that progression, 1.750. And that's just to make this part centered on the strip progression. At this point, I am going to apply these changes. At the very top, there's an icon called Apply. If we hover over it, it gives you a list of the changes that are going to be done once I select it. So I will select it, and that's when all of those changes are made. There you can see the strip has been updated all the way throughout the strip. Next, I will save the strip, and we are now going to create the punches. You can see that there are two tabs at the top of the property manager here. One is the strip tab, and that's where you change parameters of the strip or add and remove parts in the strip. I'm going to go to the punch tab, and this is where we create and edit punches. First punches that I'm going to create are going to be the punches for the internal openings in the part. And this is why we left those openings in the flat blank geometry, because it makes it very easy to create those punches. I'm going to select this icon, create all the punches for the inside cuts of the selected part. I'm going to use this section right here, punches inside the blank sketch. I tell it what station I want to create the punches in. We only have cylindrical punches, so we do not have to worry about the non-cylindrical punches section. For the cylindrical punches, I'm going to have those created in station 2. Once that's made, that change is made, I just click OK. And you can see that those punches were automatically created. This red preview is just that. It's just a graphical preview showing you where the cuts will be made once we select Apply. I'm going to add some more punches. Next, I'm going to add 2 punches in the scrap of the strip for pilots. So to do that, I am going to use the Add a Cutting Punch icon. What it just did was it created a part file, inserted it into the strip assembly. You can see that here, punch number 2. And then it also, I'm editing that part file in context of the strip assembly, and it created a sketch within that part, and it placed us normal to that sketch. So it did a lot just by selecting that icon. So the first pilot pierce punch that we're going to create is going to be this one right in this area right here. First thing I'm going to do is I'm going to create or convert these 2 sketch entities into this current sketch. That's going to be for dimensioning and making relations to. To do that, I'm going to use Convert for Construction. LogoPress 3 Sketch, Convert for Construction. I'll select these 2 construction lines. This construction line is always running down the middle of the stock width, and this construction line is at the beginning of each station. When I select OK, not only does it convert it, but it makes it into construction geometry right away. So now I'm just going to sketch in a circle. The first circle is going to be, the center of the circle will be on that construction line or center line that we just created. And then I will dimension it and make it 0.277. And then all I have to do is place a vertical dimension from the center of that circle down to this construction line. And I'll make that 1 inch 750. Once I have the sketch fully defined, you can see that down here, fully defined, I can exit the sketch, and that's when that punch is created. You see that right here. And you can see the preview of the cuts going down through the strip. So I'm going to create another pilot pierce over on this side. Again, I'll use the add a cutting punch icon. It inserts another punch into the strip assembly, creates another sketch, and makes me normal to it. In here, I am going to again use LogoPress 3, convert for construction, to convert these two center lines. Again, I'm going to sketch in another circle, just like that, with the center coincident with that vertical construction line. I'm going to drag that circle down below this horizontal construction line. Then I can dimension it like this with a 0.250 dimension and dimension the diameter 0.277. Once I am done, I can see I'm fully defined again. I will exit sketch. And there's my second pilot pierce. The next punch I'm going to create is going to be a notching punch on the back side of the strip. Again, I will select add a cutting punch. It inserts another part file and puts me into another sketch. You always want to create and sketch in each punch independently of the others. You don't want multi-bodied punches. At this point, I'm going to sketch in the general shape of the punch. And it can be any enclosed shape, but I'm going to use a rectangle. And I'm just going to sketch it in. And you can see I'm sketching it in station 2. And I'm crossing this horizontal blank sketch entity. What we are seeing here is not the part, but just a sketch representing the blank. Once I have that enclosed shape in here, like this, I go to LogoPress 3 Sketch and select Search the Punch Outline. What it's going to do is convert any entities within that enclosed shape from the blank sketch, and then it will also trim. At this point, we can create some dimensions and whatever entities that we need to define this punch. The first thing I'm going to do is I'm going to convert, actually first I am going to create the punch mismatches. So I'm going to create a punch mismatch on this corner. So let's zoom in there. And I'm going to use a LogoPress function called punch mismatch. And click on it. And you can see there are 3 different types of punch mismatches. But I'll be using the last one right here. Punch mismatch number 3. The first selection is always going to be where the mismatch divot gets cut in. Then, which is in this case going to be a horizontal line. After that, focus drops down and we can select the adjacent line, which will be the vertical line. Once we're done, we click OK, and it will create the punch mismatch sketch entities. Now these are just simply SOLIDWORKS sketch entities and dimensions. I can then create some fillets on here. I'll just use the SOLIDWORKS fillet tool for that. I'll create a couple of 1/8 inch fillets on the back side, and then a 15 thousandths fillet on this front corner right here. At this point, I'm going to convert these two vertical lines right here for dimensioning to. And I'll go to LogoPress 3 Sketch, Convert for Construction. I will then dimension from here to here, 0.550, and I'll place that same dimension from this construction line to this edge, 0.550. This way, if the progression of the script changes, this punch will grow, the length of this punch will grow and shrink with that progression change. One last dimension to place, and that is the width front to back, and I'll make that 5/8 or 0.625. Our punch is now fully defined, and I can exit the sketch. If I go to the front view, so I'm looking down from the top, we can then preview our mismatch notch. You can see how that works. We put a little divot here, and then we cut past it so that we're not going to pull a sliver or drag a sliver down as we're cutting. We're doing a nice clean cut here. I am then going to create another punch, and that's going to be a notching punch right here. So I'll go and I'll select the Add a Cutting Punch icon. Again, it creates another part file and puts us into another strip or sketch. And I will zoom in, and I'd like to create all my punches in on the same station, and then I can always move them around later. So I'm going to create this punch right here. Again, I'm going to use the corner rectangle to create my enclosed shape. So I'm going to draw my rectangle in like this. So I'm crossing the horizontal line of the front of that tab here, and also in this station, and I'm crossing these arcs up here. At this point, I can go to LogoPress 3 Sketch and select Search the Punch Outline. You can see it converted all of the blank sketch entities that were within that enclosed shape, and it also trimmed. Now these entities up here we don't need, so I'm just going to zoom in here, window around them, and delete them. I'm also going to delete this horizontal sketch entity and just drag the endpoint of this converted sketch entity to that endpoint. Just like that. Next, I'll just drag this over a little bit on each end so that we can create our punch mismatches. I want to make sure that this line is long enough. So I'm going to go to LogoPress 3, Punch Mismatch. Again, I will create a punch mismatch number 3 in this area First, I select the horizontal line on the part because we want the mismatch divot to go into the part, and then the adjacent vertical line. At that point, we just select OK, and it creates those sketch entities. Again, these are just sketch entities with dimensions once they're created. If what you created was incorrect, you made the wrong selections, you can always delete these sketch entities and then recreate your punch mismatch again. That is easier than trying to undo what LogoPress had just did. At this point, we can create some fillets. So I'll go to Sketch, Fillet. I am going to create a 15 thousandths fillet right there. And then some 1/8 inch 0.125 fillets on these two corners. We're still under define. I have to define a couple more things before we can exit the sketch. And I am going to convert these two vertical construction lines. So I'll go to LogoPress 3 Sketch, select Convert for Construction. And it's always better to convert these entities into the current sketch that you're in than to dimension to them directly. That creates a stronger relation. Better practice. Then I will dimension from this line to this edge of the punch, and I will make that 1 inch 500, and that same dimension will be placed over here. Then I just have to place the dimension on the width of this punch front to back. A lot of people would want to dimension from this edge to here. The problem with that is that this edge will get cut away, and then this dimension will have nothing to dimension to and lose its relation. So I'm going to delete that and dimension to something that was converted off the blank sketch. And I'll just make that an even 2 inches. Actually, make that 1 inch 250. At this point, we are fully defined, so I'm just going to exit the sketch, and that punch is created. You can see the preview of the cut here, and if we zoom in, we can double check our bypass on our mismatch. That looks good. And we can create one more cutting punch, and that's going to be the cutoff punch in between here. So I'll select Add a Cutting Punch. Again, it inserts another part file to the strip assembly, punch 6, and puts me into a sketch and normal to that sketch. I'll zoom in over here, and notice I'm drawing this cutoff punch right in line with the other punches so I can see the interaction between them. So again, I will create a corner rectangle, and I'm just going to be crossing these two arcs, because then when I go to LogoPress 3, search the punch outline, it converts and trims. I can then drag this up, something like this, and drag this down like that, and place in a couple of dimensions. I am going to place in a dimension from the center of this arc to this edge, and I'll make that 1.4375, and then a same dimension from the center of this arc down to this edge, 1.4375. I can then put some fillets on these four corners. So I'll go to SolidWorks Fillet, and I'll create a 50 thousandths radius or fillet on each one of these four corners. And you see the bypass here into these other cuts, because you can see the preview, the red preview of the other punches that were already created. So I will exit this sketch. I'm fully defined. And you can see the final cuts. So now, if I zoom in, I can move my punches around before I apply all of these cuts. I might as well get them into position first. So I am going to select a punch, and when you have any punch selected, you can adjust the penetration into the die. You can see that here. 60 thousandths, and the overall height of the punch. And when you change one of these, it changes the height or the penetration for all of the punches, unless you have a selected punch that is set to be independent of the others. The other thing we can do is we can I have this punch selected, and I can move it from station to station in the strip using these arrows. I will move this just over to the left one station, so it's in between stations 3 and 4. I will then select the cutoff punch, and using the arrows, I'll move it down to the end of the strip in between stations 7 and 6. Once I have all my punches in place, I can then select the Apply button. Notice I am not selecting OK, I am selecting Apply. If you ever click OK and exit the strip layout function, you can always get back into it using the Create Edited Strip Layout icon. I will select Apply, and it's going to apply the punch moves and the cuts. Okay. Next, I am going to create some form punches. Form punches can be created in the strip assembly, or they can be created in the tool assembly directly. I will create these form punches in the strip assembly, and then later on we will mount them into the tool. To create a form punch, you select this icon, Add a Form Punch or a Form Die Insert. There we go. Now we're in the Form Punch Property Manager. The first thing it's asking for, it says select the formed area on the strip. Select the faces that are bent by the punch. If I zoom in, I'm going to create the form punch for this bent tab. So in this case, I am going to select this outside bent face, somewhere towards the center. Once that's selected, I can then enter a file name. You can see mine is defaulting to a form punch. That's fine. I can select a material, and I either can type in and enter a heat treatment, or I can select it from the list. Every time that you enter a heat treatment, it adds it to this list, so you only have to enter it once. Next, I am going to select the type of punch, and you can notice that I'm just starting at the top and working my way down with my selections or enter my values. Type of punch, you can see that there's a 3D punch and 3 different types of 2D punch. The 2D punch that we want to select is 2D punch number 2, where we're going to coin or set that radius. After that selection is made, we can change our punch height, but right now it's defaulting to the same height of the cutting punches, so I'm just going to leave that. Then, just to the left of that value is this icon, Punch Body Sketch Definition. When I select this, it puts me into a sketch looking down from the top, and you can see it zoomed me right into the area where that punch is going to be made. So I'm just going to sketch in a rectangle like this, And then I'll place in some dimensions and add some chamfers. So first I'll add my chamfers. I'll add a couple of 100,000ths, 0.100 chamfers on the front edge, front corners I should say, and then a couple of 0.180 fillets on the back. Next, I'm going to put in some relations and dimensions to the part itself to orientate or position this punch. First, I am going to place a center line from the center point or the midpoint of this edge to the midpoint of that line right there, and then make it vertical. That centers the punch onto that formed edge. Then I'll place a dimension on that center line and make that 30,000ths. I will also place a dimension on the width of this punch, 1.250, and then a dimension front to back and make that 0.750. You can see we are fully defined now, and all I have to do is exit the sketch, and it puts me back into the Form Punch Property Manager. And at this point, we can now see a preview of the form punch. Before, we could not see that preview because we did not define what that punch is going to look like looking down from the top. At this point, this is just a graphical preview. If I cancel out, it would just disappear. We can change some dimensions. You can see we can change the angular dimension. I can change how much is squeezing or setting that radius. The bypass value, how much is bypassing the radius size here. We could make changes to all of that. If you do make a change, say let's change this angular value to 5 degrees instead of 15, you have to select apply. So that change is made. Okay, now we will just check OK and create that form punch. And it places us back into the strip layout property manager. Next, I am going to create the die block on the underside of this station. Again, I will use the form punch form die icon again. It puts us back into here. It says select the faces that are bent by the punch. Well, because this is on the die half, I am going to select the other side of the radius, of the formed radius, the inside. I can give this a name. I will just say this is the form, instead of form punch, this is the form die. Give it material and heat treatment. You can see it's just defaulting to what we had last selected. For our type of punch, I'll select it from this list, and I'll select 2D punch number 1, profile sketch with radius overlapping. That will mean that it will come around this radius and out this way. The height of our punch, I'll just leave that for now, and for the punch body sketch definition, I will select this icon, and it puts this into a sketch just like it did for the other punch. I then will sketch in a rectangle, something like this. I'll just zoom in down here because I need to make this edge of the rectangle coincident or collinear with the inside face of the bend. Notice that I cannot make that selection. You have two options to make this selection. You can either change the display style to hidden lines visible, and then you can make that selection, or if you hold down the shift key, you are able to select through the transparency, as you can see. So I will hold down my shift key, select this edge, and then hold down the control key and select this edge, and I will make them collinear. At this point, I just need to place a couple more dimensions, and to make those dimensions I will need to convert this vertical construction line. So I will go to LogoPress 3 Sketch and select Convert for Construction. Select that vertical center line. And then I am going to drag this edge right here so it's to the left of that center line, because that's where we need it to be, and dimension from here to here. And I'll make that dimension 0.625. I then just need to dimension my width, 0.325. I'm sorry, 3.250. And then a dimension front to back, 3.500. We're fully defined now. We can see that down here. And I am going to just exit out of the sketch. At this point, we get a preview of the punch. All I need to do is adjust the height with this punch length value and make that 1 inch 250. Once everything is set the way we need it, all we do is we check OK, and that punch is created, or in this case die block, and it puts this back into the strip layout property manager. There are just two more form punches that I'm going to create, or actually a form punch for the dimple and a form die for the dimple. Technically, these do not have to be made in the strip. They could be just created directly into the tool assembly, but just for the sake of this exercise, and some people do like to see that all in the strip assembly, we'll create them here. So I'm going to again select the Add a Form Punch icon. Formed area on the strip, I am just going to select the two top faces of the dimple. I can then you can see here that the type of punch is defaulting to a 3D punch. It is grayed out. You cannot change it because the faces that we had selected here, that's all that it could be. I am then going to select the punch body sketch definition icon. And I am going to just convert this edge of the dimple convert entities, and then exit the sketch. We then get a preview of that dimple punch, and I'll click OK. Next, we just have to create the die for that dimple. So again, I'm going to go into the Form Punch Form Die, select the Form Punch Form Die icon. I'll select the faces of the dimple on the die half of the part. You can see again, it is defaulting to 3D punch and it's grayed out. So all I have to do is go into the punch body sketch definition. Looking down from the top, I will just sketch in a circle centered on the dimple, and I will just dimension it 0.4375 and exit the sketch. You can see our insert. All I have to do is change the height of that punch 1.250, so it's the same as this one, and click OK. We have all of our punches in here. At this point, we're not going to make any adjustments. So at this point, this is when we can click OK and exit the strip assembly. It's telling me that I have one postponed action that's not applied yet. I'll say yes, apply that. And also at this point, we can take and have LogoPress calculate information and populate it into a note. I'm just going to leave everything at default. There you can see everything's checked right here and select yes. It's doing some force computations, and it creates a note. And you can see over here, here's the note. It tells you the step, the strip width, and so forth, all your cutting forces and forming forces, and it also gives you forces for each individual punch. Our strip is now complete, and let's hit save. Once the strip assembly is saved, we can start creating the tool assembly for it. We are going to use a LogoPress function called tool structure to do this. So while still in the strip assembly, just go up to the tool structure icon and select it. A Save As dialog box will open, and what we need to do is first tell it where we want to save this tool assembly. In this case, I do not want to save it in the strip assembly folder, so I'm just going to go up one level to the main folder. Then I am going to enter a file name called tool assembly. Just like with the strip assembly, I call my strip assembly. I'm going to call all my tool assemblies tool assembly, because again, what makes it unique, all the files unique, is the project name. Right now it is defaulting to the project name that was assigned to the strip assembly that we currently have open. This project name will get added to every file in this tool assembly, making it unique. Next, I am going to select a tool template from this drop-down list, and I am going to select the tool template called Tool Template Right to Left Feed, and we get a preview of that tool template. Then I will select Save. The tool templates are very easy to make, and they should include as much as you can without you having to start removing stuff from it every time you go to use it. So now we have our tool assembly created, and tool structure automatically opens. The first thing I do when a tool assembly is created is select Save, because technically it's not saved yet. The first thing that we're going to do is we're going to resize the die set. The upper punch shoe and the lower die shoe are tied together. So if we change the size of the punch shoe, the die shoe will resize accordingly with it. So with focus in the Select to Plate box, we can select plates within the tool assembly and alter them or modify them. We can also select plates from the plate list down below here. What I'm going to do is I have focus in the select a plate box, and I'm going to select the punch shoe. With that selected, I am going to scroll down to the plate dimension section, and here we can see we can adjust different dimensions associated with that punch shoe. I am going to change the X dimension to 22 inches 0.25. You will see that sometimes the position of the pins is not updating correctly to the position of the holes in the die set. This is just a rebuild issue, so I will click in a blank spot within the graphics area and do a Control plus Q rebuild. That is a much deeper rebuild than the stop and go light symbol up here, and I recommend that you use Control Q instead of this from now on. Once the die set has been resized, we can then start resizing some of the die block in the lower assembly. You can see that LogoPress created automatically, because this creates automatically an upper, a middle, and a lower sub-assemblies within the tool assembly. And you can see that it automatically inserted the strip assembly that we had open when we started up tool structure. We can use the LogoPress filters at the top here to view those different sub-assemblies. You can see that we can look at the lower, we can look at the middle, the upper, and any combination of those. We can also toggle the strip assembly to hide and show it. I'm going to use this icon to look at just the lower half of the tool. At this point, I am going to resize this die block at the beginning of the tool assembly. To do that, again, I can either select it from the list or put focus in the select a plate box and select the plate in the graphics area. Once that's selected, or any plate is selected, we have different options that we can use to modify this plate. We can delete a plate from the assembly. We can rename a plate. We can add colors to a plate. We can change the material, the heat treatment, or add a description of that plate. And these are all custom properties within the part file. I'm going to scroll down to the plate dimension section and change the X dimension again. I am going to change the X dimension to 14.750, and you can see that our die block size is just updated. The Y dimension I'll leave at 10 inches, and the Z dimension I'll leave at 1 1/4. Next, I am going to add another die block at the end of the tool assembly, and that'll be for cutting this part off. To add a plate, I'm going to scroll up to the top of the property manager and select the Add a Plate icon. The first thing we can see that we switched over to the Add a Plate property manager. The first thing in this property manager is asking you to select is what tool assembly are we going to place this plate into. From the list, let's select the lower. Next, there are 5 different options to create this plate from. Plate from a template, an instance of an existing plate, meaning that if you add another, it will be a quantity of 2, or a copy of an existing plate. Both plates are unique and independent of each other, so you have a quantity of 1 and quantity of 1. Plate from a sketch, this would put you into a sketch looking down from the top, and you would sketch in the size, shape, and position of that plate, and it would extrude it. And the same, very similar, is the plate from revolve sketch. Again, it would put you into a sketch but from the side, and you would sketch in 1/2 of the revolve with a center line, and it would automatically revolve it. We are going to use plate from template. Let's select the template that we want to use right here from this pull down list. And the one we're going to use is called plate. It's just a rectangular plate, as you can see in the preview. From the for the name of the plate, we can either enter something into here, and every time you type something in, it adds it to this list. I'm just going to select it from the list here, die block. Next, I'm going to select a material from the material database. I'm going to select A2 for this particular plate. And then I can either enter a heat treatment or pick it from the list. I'll pick it from the list, 5860. Since we have the descriptive name entered, I am not going to enter a description custom property. I will leave this blank. The next thing it's asking for is the plate Z position. For the plate Z position, I am going to select the top of the die shoe. You can see once I have that Z position face selected, it then drops down to the plate X position. For the plate X position, I am going to select this left-hand face of the die shoe. It then drops from the X position down to the Y position. This I'm going to leave blank, because if you leave any one of these particular position boxes empty, it will just go from the plane or origin of the plate being inserted to the origin or plane of the assembly that's being inserted into. In this particular case, the Y position will be top plane to top plane. We also have a adapt dimensions section right here. If I had this checked and selected something, the plate would come in, would be resized to the plate that you have selected. We are not going to do that right now, and we will just select OK. This is warning us that the name that we had selected for this particular plate is already used, and it will say, do you want LogoPress to add a 123 addendum to the end of the file name? Or we could select no and enter another file name on our own. We're going to select yes. And this block is now inserted into the lower assembly of the tool assembly. First thing I'm going to do is I'm going to resize this die block. I'm going to scroll down, and for the X dimension, I'll enter 4 inches. For the Y dimension, I'll enter 3.5, 3.5. And for the Z dimension, I'll enter 1.25. You may have already noticed that the die block is coming out adjacent from the face that we selected. We want it to come in on top of the die shoe. To change this, we just go to our plate position section, make sure that we have focus on the X plate position, and then select this icon. Switch between adjacent or superimposed plate positions. When I click on it, we get a list. You can see that it is set to adjacent. We want to change it to be superimposed. Once we've made that selection, you can see that it changed it from being mated from this side of the plate to being mated to this side of the plate. LogoPress is creating mates. You can see that there is an X mate, a Y mate, and a Z mate. Now we will insert a stripper plate. I'm going to scroll up to the top and select Add a Plate again. I am going to use my filters to display the entire tool again. Since this is a stripper plate, you can see we are in the Add a Plate Property Manager. I am going to select from the list here the middle assembly. That's what we're going to insert the stripper plate into. Again, we will use plate from template, and the template we will use is called plate. So that's defaulting to what we had last used. For the file name, again, I will just pick it from the list, stripper plate. Then select the material. I will choose 4140 heat treat, and the heat treatment I will leave blank because we selected 4140. You can see focus is already in the plate Z position box. I'm going to rotate around, and I'm going to select the top of the first station of the strip assembly. And the reason I do this is because that first station is most likely never going to get deleted. Select there. Once that Z position is selected, it places the focus down in the X position, and I'm going to select the right hand face of the die shoe. And then focus drops down to the Y position. I will leave that blank because again the plate will come centered onto the top plane. I will then check OK, and we'll get a warning that is telling us that it's going to create a external reference. That's because we are placing the stripper plate into the middle assembly of the tool. But we selected faces for mates in the strip assembly and also in the lower assembly. So it's going to create external references to create those mates. You can either select no and then come over here and make changes, or in this particular case we'll select yes. And our stripper plate is now inserted. We just need to resize it. I'm going to scroll down, and for the X dimension I am going to enter 22.250. For the Y dimension I'm going to enter, or I'll leave it at 8 inches. And for the Z dimension, I will also leave, I will leave that at 1 inch also. The next plate that we're going to insert is going to be the punch plate. And we're going to have 2 punch plates on the top. So for the first plate, I'm going to select Add a Plate. And since it is a punch plate, I'm going to insert it into the upper assembly. Again, we'll use plate from template, and the template we're going to use is called plate. I will enter a file name or pick it from the list here. I'll just select punch retainer. And for the material, I'll select A2 and I will enter my heat treatment. Focus is already in the plate Z position, so I'm going to rotate and select the bottom of the punch shoe. Focus then drops down to the X position, and I'll select the right hand face of the punch shoe. The plate Y position, just like the other plates, I am going to leave that blank so it comes centered on the tool assembly. This time I will use the adapt dimensions function. So I'll check the box here and I will adapt the size of the first die block in the lower assembly. And you can see that is selected because it is purple. Once that is selected, I will click OK. And our first punch retainer plate is inserted. Again, it is coming out adjacent from this selected face, so I will change that down here in the plate position section. Focus is already on the X plate position, and I'll select the switch between adjacent or superimposed plate positions. I'll make that superimposed. With the position of the plate corrected, I can then just change one dimension for our plate dimensions, and that's going to be 14.70 for the X dimension. You can see how using the adapt the dimensions option can save you some time either remembering or measuring dimensions of other blocks if you need them to be a very similar size. And we have one more plate to insert into this tool assembly. So I'm going to scroll up and select add a plate. And again, I'm going to put it in the upper assembly. Use plate from template and the template called plate. I will enter a file name called punch retainer again, and the material will be A2 and heat treatment 5456. The plate Z position, which we have focus here already. Again, I'm going to rotate, so I'm looking at the bottom and select the bottom of the punch shoe. I can use my filters up here if things are confusing. I could just make it so that I'm looking at the upper half of the tool. Next, you can see focus is down at the plate X position, and I can select the left-hand face of the punch retainer. Here, I can add a gap distance automatically right here. If I wanted this to be 0.05, I could enter that here. I am going to leave that blank to show you where you can enter in that gap distance in the other property manager. We can also change our adjacent and superimposed plate positions with these icons for each the Z, X, and Y plate positions before it even gets inserted. Again, I will adapt dimensions, and this time I'll adapt dimensions from the punch retainer plate that we already have in here. I'll click OK. Again, it's telling me you've already used the name punch retainer, so I will let the LogoPress add a numbered addendum to it. Once that plate is inserted, here is where we can add a gap distance. Right now you can see I have focus on the plate positioning, X plate position, and I'll enter 0.050 for a gap. And if I zoom in here, you can see that the plate moved off to the right in a positive direction because we entered a positive value here. We can either enter in a negative symbol or just click on flip the gap distance direction icon. And now you can see that the gap is going off to the left. We just need to resize the plate now. So for the plate dimension, all I need to do is change the X dimension. And I'm going to change that to 7.5. We now have all of our plates in our tool assembly. I'll just show the rest of the tool with display the whole tool icon. I can now exit out of tool structure and either come up here and select save, or what I'm going to do is select Control S and save my tool assembly. I suggest that you get used to using keyboard shortcuts instead of having to come up here and select icons all the time. I will now create clearance in the stripper plate for the two rails at the beginning of the die. This is done using a SolidWorks cut extrude feature. First, I'm going to isolate the necessary parts so that the other parts are out of the way and we can see things better. First, I'm going to select the stripper plate, and then holding down the control key so I can multi-select, I'm going to select the two guide rails. At this point, I will right click and select isolate. The other parts are then hidden, but we can always bring them back by selecting exit isolate. The first thing I need to do, since I'm going to be creating this clearance in the main tool assembly, is I need to edit the stripper plate in context of that assembly. So I'm going to select it and then select Edit Part. We are now editing this part in context of the tool assembly. This is very important to do because if we did not do this, any features that we created would be in the assembly and not in the part file. Next, I'm going to start a sketch on the bottom of the stripper plate. So I'll click on that face and then select Sketch to start a sketch. Also, I'll make my view normal to that sketch. And you can see that there are sketches here included with the template. And we could, and we can, simply convert these sketch entities into this current sketch and use that to extrude the clearance. So I'm going to start up the Convert Entities tool, and I'm also going to select this option right here, Select Chain. That way I can just click on a sketch entity and then it selects the entire chain. I will do the same thing for this entity over here and then click OK. I can now, while in the sketch, start the extruded cut feature. I'm going to choose the option Offset from Surface and click on the top of one of the rails. You can see that the depth is in fact offset from that face. Right now it's at 1/8 inch, but I also want that to be a little bit deeper. I'm going to make it 5 thousandths deeper so that when there is no stock being run through the die, it will balance, the stripper plate will rest on top of the rails and be balanced on top of them. So I am going to reverse the offset and change the value to 5 thousandths. And then click OK. We can now see that the clearance is cut into the stripper plate. I will now exit out of editing that stripper plate and also select Exit Isolate, and the rest of the tool is shown again. Next, I'm going to also add 2 components at the end of the die here that the stripper plate will balance or rest upon when there's no stock running or ran all the way through to the end of the strip. These will be, I will be using a standard component called a stop block. So I select the standard component library and I'm going to select stop block. First thing it's going to ask for is your base face. What is that stop block, the base of the stop block, resting upon? That's going to be the top of the die shoe. Once we make that selection, you can see we have an axis being determined. And then I'll select the stop block length face. That's going to be the bottom of the stripper plate. After I make those 2 selections, I get a preview of that standard component. I can then come up to the top and select my supplier. I'll leave it at generic inch. Also, I can select my diameter for it. And I will select 1 1/4 inch diameter, and also have a 3/8/16 screw in it. You can see our preview just updated. I can also add in a stop block length, a custom length. It defaults to the length of the 2 faces that I have chosen, but I'm going to say I want that to be 5 thousandths smaller, so I'll type in negative or minus 5 thousandths. And my overall length just updated. At this point, I'll just select OK, and it puts me into a sketch looking down from the top. I am going to use my LogoPress 3 filters, so I'm just looking at the bottom, the lower, and the middle. And for right now, we have to place sketch points for the positioning of the stop blocks that we're putting in. I could just put in a SOLIDWORKS sketch point and dimension it, but LogoPress has a tool called Position by 2 Edges, and I'm going to use that. So I'll go to LogoPress 3, Position by 2 Edges, and I'm going to set the 2 values to 3/4 inch, 0.75, and this value is also 0.75. So the first selection, I can select one of these 2 edges of the stripper plate. So I'll select that edge, and then I'll select this edge. And you can see it placed a point and automatically dimensioned them. I'll do the same thing up here. And there's my other stop block. Or in this case, I'll call it a balancer. I can then cancel out of that Position by 2 Edges function. I'm still in the sketch. What I am seeing here is just a preview, but once I exit out of the sketch That's when the holes and the components are created, as you can see. So now that we have our clearance and we have our balancers at the end here, so now as we start feeding stock through the tool, the stripper will stay level and not be cocked in one direction or the other. Next, I'm going to adjust the sizes in the rail and tray assembly. To do this, I'm going to start up tool structure again. And since the rail and the tray are part of an assembly, we have to select it from the list. We cannot select it in the graphics window. So I'll click on it in the list here, lower part, rail and tray assembly. And if I scroll down, you can see that we have many dimensions that can be controlled or modified right from tool structure. So our rail spacing, that is the spacing between the two guiding faces, of the two rails, I'm going to change that to 4 inches 5/10. So I added 10 thousandths in between them beyond the width of the strip. Next, our thickness I'll leave at 3/4. Notch distance Z, I'll leave that at 1/8 inch. That's this distance. Our width I'll leave at 1.25 inches. But I will change the length of our rails. The length of the back rail, I'm going to make that 6.5. You see it just updated. And the front rail I will make 10 inches. Just like these values right here, the stripper clearance in the Y and the stripper clearance in the X right here will adjust this sketch right here, and then of course, since our clearance in the stripper was converted off of that, that would automatically update. We also have our stripper clearance radius. And since we are done modifying this rail and tray assembly, we can exit out of tool structure. We'll now save the tool assembly. And this information note is in a sketch, so if you would like to hide it, you simply have to go to the Hide Show Items and select View Sketches, and you'll hide the sketches. I would also like to show you that if I hide the entire tool, you can see that all the punches are still in the strip assembly, and that there's no punches in the tool assembly, and there are not any openings in the plates either. They have to be mounted into the tool. So I'm going to select the LogoPress punch mounting icon. And the first thing it's asking for is what punches do I want to mount. So I'm going to hide the tool again and select this punch and this punch. Because if I select multiple punches, they have to be within the same punch retainer plate, which these two are. We will not be mounting the cylindrical punches because they will be purchased punches, which would be inserted using standard component library. Next, I could enter a file name for each one of these, but I will leave them at the default, which is the same as the name of the punches in the strip. I will then enter a material, A2, and select my heat treatment. Then I will put focus in the punch plate box, and I'll select the punch plate. Once I have the punch plate selected, you can see that the other plates are automatically populated. The stripper plate, the die plate, and the bottom plates, which is the die shoe. For each one of these plates, you can enter in a gap distance, and you can also select the hole type. For the punch plate, I'll leave the gap distance at 0. For the stripper plate, I'll enter a gap distance of 20 thousandths. For the die plate, make sure that your hole type is set to standard draft, and the die clearance is going to be 10% of the material thickness, which will be 5 thousandths. The die land, make that 0.250, and 1 degree of draft. The bottom plates, I'll put focus on the die shoe in the list here, and for the clearance I'll enter 100 thousandths. Once all of that information is set, just select OK, and it will mount the punches. What it just did was created a derived part of each of the punches that we mounted and placed the mounted punch, the derived part, into the upper assembly of this tool assembly. If I take and hide the strip assembly, you can see those punches are now in the upper. If I look at the upper assembly, there they are. It also created openings in all the plates. And lastly, if I hide the tool and show the strip, you can see that the punches are hidden. The punches in the strip assembly are hidden in context of the tool assembly. If I were to open up the strip assembly, they still would be visible there. And now those two punches are mounted. Next, I'm going to mount the end cutoff punch. So I'm going to go back into punch mounting. And again, I will hide the tool and select the punch I would want to mount. I will then select my material type and enter my heat treatment. I'll show the rest of the tool, put focus in the punch plate box, rotate, and I'll select this punch plate. Again, it populates all the other plates into the appropriate areas. Now, if it does populate a plate that you do not want a hole in, say this parallel right here, we don't want a hole coming down all the way through it. So I just select it from the list, and then I just remove it. Right click and delete it from the list. And now it's not going to put a hole in that plate. With parallels, most often you would just mill a ramp in the area where the slug would drop through. You can also see that the clearances and hole types are defaulting to what we had last selected. So I'll just make a quick check to make sure that they are fine and click OK. And now that punch is mounted. Next, I'm going to mount this form punch. So I'll go into punch mounting, hide the tool, select the punch I like to mount, show the tool again, put focus. You can see I have the material and heat treatment set. It is just defaulting to what I had last set for the last form punch. Punch plate, and select my punch plate. For form punches, you will only have a section for the punch plate and bottom plates. There will not be a section for stripper or die plate. For the punch plate, we are going to modify the sketch for the opening in that particular plate because this punch has chamfers on the corners and we do not want chamfers in the opening. So for the punch plate, I'm going to select this icon, Edit the Punch Passage Sketch. It then puts you into the sketch for the cut extrude that's going to be created in that particular plate. I am going to use a LogoPress sketch function called Sketch Fillet Management. In the Function tab, select the Chamfer to Fillet option, and then from the list we select our radiuses. These chamfers right here are 100 thousandths, so I'm going to select the chamfer or the radius size of 0.94, and then you simply select the chamfer on each side, and you can see it changed them or added a fillet. Then for these chamfers right here, which are 180, I will select a chamfer size or a radius size of 156 and select each one of those chamfers. When I'm done, I check OK and exit the sketch. Puts me back into the punch mounting property manager. And then for the bottom plates, which is the stripper plate, I select it from the list and then select Edit Punch Passage Sketch icon. Puts me into the sketch the sketch for the cut extrude in the stripper plate. And again, I will use the LogoPress 3 Sketch Fillet Management icon. Chamfer to fillet, and I select my radius size, select the two chamfers there, change the radius to the 0.94, and select these two chamfers. And then exit the sketch. Once you've edited the sketches for the punch plate and the stripper plate, just check OK, and that punch will be mounted. We have one last punch to mount, and that's going to be the die block, the form die block on the bottom of this form. So again, I'll go to LogoPress 3, punch mounting. I am going to show just the lower half of the tool. The punch to mount, I'll populate it into this box. Again, you set your material and heat treatment. Put the focus in the punch plate box. And this time, This particular block is not inside of another plate. It's not being retained by anything. So for the punch plate, I select the plate that is going down or up to, which is the die shoe. But I have to check this option, no punch retainer. That means that it is going to go up to the selected plate, but not through it, and it's not going to create an opening in that plate. I can then check OK, and the form die insert is now mounted. I can then save the tool. I am now going to work on the remaining unmounted pierce punches in the strip assembly. We could mount these remaining pierce punches using the punch mounting function, just like we did with the other cutting punches. But then they would be a stick punch that would be manufactured in the shop. We want to insert them as a purchased shanked bodied punch, and we will do that using the standard component library. I'll select this icon, and all of our cylindrical punches are in this using this icon right here. Once selected, a larger menu will pop out, and you can see we have shank punches with and without ejectors. Also, we have blanks, straight punches, and ball lock punches. I'm going to select this one, cylindrical head shank punch with an ejector. The first thing it's asking me to select is, well, which punch are you going to mount? I'm going to select one of the two 1/4 inch punches that are in the part. So I'll select this one. Next, it's asking me to select the plate that the head of the punch is in. So I need to show the rest of my tool using the LogoPress filters. And then I'm going to rotate, so I'm looking, or I can select the bottom of the punch retainer plate. Now this is important to make this selection correctly, because this first selection for any standard component is going to determine the direction of the axes. If I selected the side of the plate, the axes would come out sideways. I am going to select either the top or the bottom of the punch retainer plate. And now you can see that the axis is vertical. Focus then drops down to the die plate box. I'll select the die block. Once that is made, you will see we get a preview of the punch. You will not get a preview of the punch until those two selections are made. Next, we would select the stripper plate. We can see focus is already in the stripper plate box, and I'll make that selection. Once those three selections are made, I am going to scroll up to the top of the property manager and start making selections and entering values from the top and working my way down. First, I am going to select what supplier I'm going to use for this punch. I am going to select Dayton Versatile Inch. Next, I would select what body or what diameter shank is going to be used for this punch. I'm going to select 0.437. Here, this is the length of the punch. That is being determined by this value right here under die plate. How far it's penetrating into that block. Right now I have it set to 60 thousandths. I can also select from here the length of the point of that punch. You can see I already have selected a 3/4 inch long point. The point diameter has already been entered. That is because we had selected a punched amount. I am then going to scroll down and select put focus in the stripper plate. Over here in our single machining, this is telling me what hole type and size is going to be created inside of that particular plate. Right now, the through hole, the D0, is set to be the same diameter as the punch. So I am going to add some clearance. So I'm going to add, I'll just say, I'll add a 32nd to this size. So I'll put plus 0.031, which makes it 0.281. This right here is the clearance for the shank. I'll just leave that at 468. And the depth of that counter drill, I'll make 3/4 of an inch. Next, I'll put focus in the die plate box. And then I am going to come over here to the single machining. You can see for this plate, it's defaulting to a straight through hole. I am going to change that using this icon, change the hole type. And I'm going to select a hole with land and taper. Right now you can see that clearance has already been added to this hole diameter. That's because we have die clearance already entered, but I'm going to change that to 5 thousandths per side, but the value that you enter here is an overall value. That's why it says diameter. So 5 thousandths per side will be an overall of 10 thousandths. And you can see our hole size then updates. Over here is our land length. This right here, the L1, and I'll make that 1/4 inch. Next, I need a clearance hole for the slug to go through the die shoe. That would be entered under other plates cross through. So I'll expand that. And with focus in this box, I'm going to select the die shoe. I then need to double check the clearance. Right now you can see it is just a little bit larger than the bottom of the draft, so I'm going to change that to 0.3125. Once all of our settings are set and they are at where we would like them to be, we just check OK, and it'll place us into a sketch looking down from the top. You can see that there are 2 sketch points already placed for each of those punches. This is because we had one punch in and then another instance of that punch in this location. We can always either add or remove sketch points, but this is exactly what we want. So I will exit out of the sketch, and this is when it will create the holes in the plates and then insert the components. As you can see, the punches are now in there. And if I hide the tool, you can see that those 2 punches have been hidden. That's because we populated them in the punched amount box. I will now move on to the 2 pilot pierce punches. You can see them right here. Again, I will go up to the standard component library icon and select it. I'll select the cylindrical punch icon, pops out another menu, and I will select cylindrical head shake punch with an ejector. For the punch to mount, I'll just select one of these two punches. Again, it goes to the head plate box, so I'll show the rest of the tool again using my LogoPress filters, and I'll select the bottom of the punch retainer plate. Once I make that selection, focus drops down to the die plate box, and I'll select my die plate. Once I've made those two selections, I do get a preview of the punch right here. Focus then moves to the stripper plate, so I am going to select the stripper plate. And after those three selections are made, again, I am going to go up to the top and work my way down. You can see it is defaulting to the Dayton Versatile Punch supplier, so that's good. We'll leave it at that. For the body diameter, I am going to select 3/8. And then I am going to select my punch length has already been determined. The point length is defaulting to what we had last used, 3/4 of an inch. That's fine. Then my point diameter is already set because I had populated the punch into this box. So I'll scroll down and put focus in the stripper plate box, and I'm going to add a 32nd to this diameter. And I'll just type in 0.3125 for my die clearance, or for my clearance in the stripper plate. Also, I'll change my L1 value to 3/4 of an inch. I will put focus in the die plate box. Again, it's defaulting to a straight through hole, so I am going to change that hole type using this icon to one with land with taper. And I'm just going to change my land depth to 1/4 inch. You can see our die clearance is already set. It's defaulting to what we had last used. I'll put focus in the other plates cross through, and I need to select the die shoe for my die clearance for the slug. Or I should say slug clearance. When I have focus on that die shoe in this box, I can come over here and enter a size for the slug clearance. I'll say 0.344. I can now check OK, and it puts me into a sketch looking down from the top, and you can see it only placed 1 point for that one punch that we had placed in the punch to mount box. That's because this punch we actually created separately. It is not an instance of this punch, but we can place a sketch point there manually. Right now you can see that we cannot select through the transparency to get to the midpoint of that punch. So what I need to do is I can either change my display style to hidden lines visible and make that selection, or I am going to hold down the shift key and that will automatically turn selection through transparency on. You can see now I can select through the transparency, and I can select the center point of that punch. Just like that. Once I have these 2 points in there, I just exit the sketch and it will create the holes and insert the components. And there we have our other 2 punches. One thing to notice though, if I hide the tool using my LogoPress filters, you can see that this punch did not get hidden. That is because it was not the punch that we had selected for punch to mount. So I'm just going to manually right click on it and select hide component. And at this point I can insert, I'm going to create the pilots that would go into the pilot holes. Those would go in similar to how the pierce punches went in. So I'll just select standard component library and select one of these pilots that are available to us. The one I'm going to select is cylindrical head and parabolic nose shank pilot. The first thing it's asking for is the head plate. So I'm going to show the rest of the tool and select the bottom of the punch retainer. Then focus drops down to the die plate just like it did with the punches. Select that. And then focus moves up to the stripper plate, so I'll select that right away. At this point we do get a preview of that pilot. So I'm going to scroll up to the top and I'm going to select a supplier from the list. Again, I will select Dayton Versatile Inch. And then I will select a body diameter. So I'll select a 5/16 diameter body for this pilot. And the point diameter is going to be 0.275. The length of this pilot, just like with punches, is being determined by this value, the penetration value. For the pilot, it's going to be the stripper travel plus the thickness of material. So the material thickness is 50 thousandths and the stripper travel is 3/8. So I will make the penetration 0.375 plus 0.05, 0.425. So then I get a 3-inch long pilot, but I need to adjust the point length. I'll make it 1 1/4 long. And then I can double check that right here. And we can see the length of our pilot point, and that looks fine. I'll scroll down and put focus in the stripper plate box. And instead of a through hole, I am going to change the hole type to a counter drilled hole. I'm going to add clearance in the stripper plate. Make that 0.344. And then for the drill depth, I'll make that 3/4 of an inch. And then the clearance for the pilot body, I'll make that the D1 value 0.375. I will then put focus in the die plate box. And this I'll change the hole type to land and taper. Again, I have to come over here and change the pilot clearance. I'll make that 10 thousandths. That's 5 thousandths per side and an overall 10 thousandths. I'll adjust my L1 dimension to 0.25, and then I need a slug opening in the die block. So other place cross through and select the die shoe. And that'll be made 0.344. This point, I can select OK. It puts me into a sketch looking down from the top. And I'll place the SolidWorks sketch points at the center of each of these holes in the strip. Again, I'll hold down the Shift key so I can select through. Place a point there, 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 with a total of 6 points in the center of each of these holes in the strip. Once I'm done, I exit out of the sketch and those 6 points are placed. Now notice I didn't place sketch points for the pilots at the end of the strip over here. That's because these pilots are in a different stack of plates. We can only place points within the same stack of plates that the pilot that those components were originally created in. So to create the pilots for these last two locations, I'm going to use a LogoPress function called standard component copy. I select standard component copy and I select the component that I want to copy. I just have to select any of those 6 pilots. Then I check OK. And you can see all of the parameters are already set for me, even the plates. But some of the plates are going to be different. So for the head plate, which is now selected for this first punch retainer plate, I'm going to change that so it is the second punch retainer plate in the die. So I'll select the bottom of this plate. And then I also have to change the die plate. So I'll put focus here and select the new die plate. The stripper plate remains the same, so does the die shoe. I always like to double check my values. It looks like everything is still correct. So I will check OK. It puts me into a sketch looking down from the top again. And then I will place a sketch point at the center of each of these holes. So again, I have to hold down the Shift key so I can select through the transparency. And I'll place a point at the center of each of these holes. Exit the sketch, and the remaining 2 pilots are then inserted. At this point, I am going to select Ctrl S to save. At any point in the design after the initial creation of the tool assembly using tool structure, you can run the LogoPress 3 animation function. So I'm going to select the tool animation icon. And when you first select tool animation, it will automatically change the display style to shaded. I always like to change the display style back to shaded with edges. And we only need to enter in 3 values. My press stroke, 3 inches. The stripper travel, 0.375. And the strip lift height. I'll make that a 16th, 0.0625. Then I only need to select play. And you can see the animation is running. We can adjust the speed of the animation using this slider. If we want to speed it up or slow it down. Now one of the main reasons you would run animation is to use the dynamic interference detection. So after the tool has run through one stroke of the animation, you select stop and then select this icon, Interferences Computation. This will check for interferences with the tool open as the strip is progressing, when the stripper contacts the strip at lift height, and with the tool closed. So it checks for interferences dynamically as the tool is animating. We get a list of interferences. We just expand them and then click on them independently of each other. We can set the non-interfering components to be at different views. I can select wireframe or even hidden. Wireframe is nice because then you can see at where those particular parts are in the tool assembly. And you just make notes as to what is interfering and what needs to be corrected. This bent leg is not cleared out in this die block. Same thing here. Right here we have an interference with the dimple on this block. We have not yet mounted our two dimple punches yet, so we'll just take note of those. Over here, same thing for our mounting of our dimple punches and die. Did not clear out for the dimple here in the die block. Same thing here and here. See, we just make notes of those interferences so that we can correct them, and then of course once that's done being corrected, run animation and dynamic interference detection again. So I will select stop and check OK to exit out of tool animation. LogoPress will remember our settings for the next time that we run animation again. I will now add a parallel underneath the bending station to support it. So I'll come up here and select tool structure and then select add a plate. The first thing I need to do is tell it what a subassembly this parallel is going to go into. So I'll choose it from the list here, lower assembly. I will use plate from template, and the template I'll use will be called lower parallel. The file name I'll leave set at lower parallel, and I'll choose a material, cold rolled steel. Focus is in the plate Z position, so I'll rotate and select the bottom of the die shoe. For the X position, I'll select the left-hand face of the die shoe, and the Y position I will leave blank, and click OK. You can see the parallel is inserted and is inserted at the end of the die set. I simply need to come down to the plate position section and put focus on the X plate position and enter in a gap distance to move it over. To get it roughly in place though, I can hold down the Alt key and then simply drag and drop the parallel in the rough area where I need it to be. What this just did was just simply change the gap distance for me. I can then just highlight it and change it to a more rounded number, say 7 inches. And you can see that the parallel is centered on the bend station. So I can just exit out of tool structure by clicking OK. Now I will edit this end parallel to add the slug clearance. If I look, though, I'll hover over this parallel. It says this is called lower parallel dash clamping. And so is this one. So what I'm going to do is I'm going to open up this parallel and add a configuration to it. So I can set this one for this with the slug clearance, and this one will be set to the configuration without the slug clearance. So I'm going to click on it and select Open. I will then go to the Configuration Manager, right-click in a blank area in the Configuration section, and select Add Configuration. The configuration name, I'll call it Ramped Slug Clearance. And click OK. You can see that the appearance of the parallel head changed. If that happens to you, all you need to do is switch back to the default configuration by double-clicking on it. Go back to the Feature Manager design tree. Expand the appearance section and right-click on the appearance that we want and select Copy Appearance. We can then switch back to the ramped configuration, go back to the Feature Manager, right-click on this appearance and select Paste Appearance. And now it looks like the other configuration. I'll go back to Configuration Manager, make sure it's set to ramped slug clearance, save the parallel, and close it. Then I'll left-click on this end parallel, and you can see that it's set to the default configuration. Well, I'm going to click on this pull-down list and set it to the ramped slug clearance configuration and check OK. Now any changes that we do will only be in that ramped slug clearance configuration. So I'm going to click on this end parallel, and we need to edit it in context of this assembly. That way any features that we add will be in the part file. I'll find it in the tree and expand it. And then I'll select the top plane and start a sketch on it. I'm then going to convert some entities. So I'm going to select Convert Entities, select this edge, and select this edge. And I got those two entities converted. Then I'll just draw a line an angular line, something like this, and then go to Trim Entities, Power Trim, and just click and drag a crossing across the areas that I want to trim. Something like that. And then get out of trimming. And then I need to add some dimensions so that I have long enough here to cover the slug opening. So I'll place a dimension here, say 1.125, and then an angular value of 30 degrees. At this point, I could come over here to Features and select Extruded Cut. If I rotate around, you can see that the top plane is not centered on this die opening. So I'm going to have a cut in two directions. For the first direction, I'll make that 1 inch. In direction 2, I just check this box, and I'll make this direction 2.5. You can see that we are covering the entire slug opening, so I will just check OK. And you can see there is our slug clearance. Next, I am going to add a fillet to this edge and this edge so that it represents the milling cutter that will come through here to cut this. So I'll come up here and select fillet. I'll set it to constant size fillet, 1/4 inch radius, and I'll select this edge and this edge and click OK. Look at it from the top to make sure that it is still covering in the slug opening, and yes it is. So now I can exit out of editing this parallel by selecting this icon in the corner here. And I'll select Control S to save. I will now create the punch and die for this dimple station. And again, I want those to be purchased items, so I'm going to use a pilot and die bushing from the standard component library. So I'll select standard component library, and then I'll select the pilot that's called cylindrical head and parabolic nose shank pilot. First, it's going to ask for the head plate, and I'm going to select the bottom of the punch retainer plate near where the punch is going to be. Then I'll use my filters to show the rest of the tool again. And now it's asking to select the die plate. So I'll select the die plate. Next it's asking to select the stripper plate, so I'll select the stripper plate. I will then come back up to the top, select my supplier, Dayton Versatile Inch. The punch body I'll leave at 5/16. The length, which is being determined by this value, so I'm going to change that to 0. And then the point diameter, I'll make that 0.150. You can see that the length has been adjusted, but I'm going to click in this pull down list and change it to a shorter B length, so 2.5 inches long, but a B length of 0.5, and that will shorten up the point length on that pilot. I will then come over here to the stripper plate, put focus there, and I'm going to adjust the size of the through hole, and I'll make that 0.156. The counter drill diameter I'll leave right here, but the length of the counter drill I'll make that deeper at 1 inch. I mean I will make it 3/4 of an inch. The die plate, I am going to add a die button down below here to use as the die for that dimple. If we zoom in here, we can see first off that our counter drill is not deep enough, so I'll go back up the stripper plate and add an 1/8 inch to that. But also that our pilot is entering in too deep. I cannot enter a penetration value that's a negative number, so we will adjust that later. The die clearance, I'll change that to 0 because I had previously measured what that opening should be for that dimple. Then I'm going to add a button using this icon right here. Choose another standard component for the die plate. I am going to choose a blank KDU. And then I'm going to adjust the size of this die button. I'm going to choose a KDU 62, meaning 5/8 diameter, and 1 1/4 inches long. At this point, to adjust the length of this pilot, I'm going to come down to the bottom under Options and select Convert into Machining Axis. This will give us freedom to make adjustments beyond what LogoPress is allowing us to do. Once I'm in Machining Axis, all of the intelligence is turned off. So at this point, I am going to select the head plate and then expand the standard component list, select the pilot from the list, and then choose Modify Standard Component. I'm going to adjust this length right here to 2.350. If I rotate, that length will be just right for the depth of that dimple. I will then check OK and check OK to the machining axis. At this point, it puts me into a sketch. So I'm going to zoom in and place a sketch point that is centered with that dimple punch. Again, I can hold the Shift key down to select through transparency and place a point centered on that punch. Exit the sketch, and it will create the openings and insert the components. The only thing we have to do is I'm going to hide the whole tool so I can see the punches in the strip, because these can now be hidden. So I'll click on this one and select Hide Components. Right click on this one and Hide Components. Then I'll display the lower half of the tool and hide the strip assembly. The only thing I have to add to this die button is a 50 thousandths fillet going around this opening. So I will click on this component and select Edit Part, and then I will come over here to Features and select Fillet, set the size to 50 thousandths, and click on this edge. Select OK. and there's my fillet running around that opening. Get out of editing that part file. Show the strip and the rest of the tool. And we can select Control S to save. I will now add some shoulder bolts to retain the travel of the stripper plate, and I will add some springs. First I'll add the shoulder bolts. I'll select the standard component library icon, and then come over here and select socket head shoulder bolt. First thing it's asking for is the base plate. So I'm going to rotate and select the top of the stripper plate. Then the shoulder bolt length plate is going to be the punch shoe. We can see that the axis is yellow. That is telling me that something in our selections is wrong. What is wrong is that we have a 1/4 inch diameter shoulder bolt selected, but the plates are too far apart and there is not a long enough shoulder bolt of this size available. So I'm going to change the diameter to 3/8. And now we can see we get a preview. I can then enter in the stroke underneath the screw head. That'll be the stripper travel of 0.375. And you can see that the counter bore is now deeper. I need 2 additional holes. So I'll put focus and other plates cross through, rotate around, and I'm going to select this punch retainer plate and this punch retainer plate, because we need holes in both of those. I will click OK. It puts me into a sketch looking down from the top, and I'm going to add 8 points. I can either start adding sketch points and dimensioning them, but I'm going to use LogoPress 3 Sketch and select Automatic Pattern. You can see we have 1, 2, 4, 6, 8, and 10 point patterns. I'm going to select the 8 point pattern, and I'm going to change this value to 0.625 in both directions. Then I will click OK on the automatic pattern, and I can make further adjustments to this pattern. These 2 points are at the edge of one of these 2 plates, so I'm going to take and make these come in a little bit further. I'll say 8 inches. Also, these 2 points are over top of the clearance for the rails. So I'm going to make this dimension larger, but you can see that it is affecting the other points. So I'm going to cancel this, and I will simply window around this point, delete it, or select this point, delete it, and I will also delete this point, and I'm going to create new ones. So I'll go up here to position by 2 edges. I'll make my first dimension here 5/8, and I need this to come in further down this way, so I'll make that 2 inches. So I'm going to select this edge for the 5/8 dimension, and then holding down my shift key, select this edge, and I'll place a point there. And I'll do the same thing here and there. I'll check OK, and I'll increase this dimension by a little bit. On this one, make it 2.5, and I'll also make this one 2.5. All our points look good. They're not interfering with anything now. So I will exit out of the sketch. And there's our shoulder bolts. I will now add the springs. So I come up here to Standard Component Library and select Compression Spring Rectangular Wire. The base plate, I am going to select the top of the punch shoe. The length plate is going to be the stripper plate. We get a preview, and we can see that it's counterboring into the stripper plate. I'm going to change this dimension so you have focus on the length plate, and then I can change this depth to 0. Everything moves up. I will choose a Danley inch spring, and I will make it 1.25 inch diameter. In the length pull down, you can choose different duties for each of that. Medium duty, heavy duty, extra heavy duty. I'll remain at medium duty. I will enter the spring total deflection. That's going to be the stripper travel plus preload, so I'll make that 0.5. And then you can see we have a percentage of compression and also the force at that compression. We only need to add other plates cross through, which will be this plate, the first punch retainer plate, and the second punch retainer plate. We can then select OK. It puts us into a sketch, and we can place our points. I'm going to place 10 springs in here. So I'll place springs over here, making sure that we're not hitting any of the punches. You can see the preview. Also over top of the form station. A couple more over here. And you can see this blue arrow here is the center of force, and as I'm placing my springs in here, you can see it's moving around. If I take and move one of these points over, you can see it just moved. Once I have my points in here, I could dimension these, but I'll leave them as they are. And I am going to, I'm going to have to slide this spring over a little bit. It's over top of a pilot. Make sure no other points are over top of a punch or a pilot. Click exit the sketch, and it'll start creating your springs. And there they are. So at this point, I'm going to save my tool assembly using Control S. I am now going to take a look at the lower half of the tool. So I'm going to come over here to the LogoPress filter, select the lower part icon, and you'll notice that this end cutoff die block is out of position. So I'm going to go back into tool structure, select the tool structure icon, select the die block, scroll down to the plate position section, select the Y plate position, and I'm going to enter in a gap distance. So I will enter 0.85, and you can see that the die block has moved to the back of the die set. We now also have clearance for the leg that's bent down in the front. I'll exit out of tool structure, and we can now insert the lifter pins. I'm going to do that using a predefined machine axis favorite. So I'll select Standard Component Library and select the machining axis icon, lower right hand corner. And the first thing I'm going to do is select my favorite. So I'll select this icon right here and select the Royal Lifter with spring. The first thing it's asking for is the top. Select the top of the die block, and next I select the die shoe. You can see that all the components are predefined along with the holes. So I can just click OK, and I'll place my points in this first die block. I'm going to place 6 lifter pins into this die block, so I'm just going to come over here and select the SOLIDWORKS sketch point icon, and I'll just place 6 sketch points. I will then make these top 3 points. I'm going to add a horizontal relation to them. So I'll select the first one, holding down the control key, I'll select the next 2. I have all 3 of those points selected, and I'll make them horizontal. I will then make this point and this point vertical, add a vertical relation, and then with this point and this point, I'll also make another vertical relation. This point and this point, make those 2 vertical, and then this point and this point, I'll add a horizontal relation. I then can add some dimensions. I'll make a dimension from here to the origin of the tool. I'll make a vertical dimension of 1.5. And then I'll make a dimension from here down to here of 2.25. And I'll make that a little bit bigger. I'll make that 2.5. I will then place a dimension from this point to this point, and I'll make that 1.250. From this point to the origin, horizontal dimension of 4 inches. Then from this to here, I'll make that 5 inches. And then I'll place a dimension from here to here. And I'll make that 4.5 inches. The sketch is fully defined, so I can just exit out of the sketch. And the lifter pins are placed as you can see. I will then place 2 lifter pins into this form block. Again, I'll go to Standard Component Library, Machining Axis, select my favorite, roll lifter with spring, top of die block, right there, die shoe right there, click OK, places me into a sketch, and I'll place a sketch point, 2 sketch points. I'll make them add a vertical relation between them. I'll place a dimension from here to this edge, and I'll make that 1.250, and then I'll place a dimension from this point to the origin of the tool, just like I did with the other one. Make that 1.5 inches. And then I will place a dimension from here to here, and I'll make that 1.25. Exit out of the sketch, and those 2 lifters are inserted. Again, I'll go back into Standard Component Library, select the machining axis, select my machining axis favorite, roll lifter with spring, top of die block, be the top of the end cutoff die block, and then the shoe. Click OK, puts me into a sketch. I'll place 2 sketch points. I'll place a vertical relation between them. I'll make a dimension from the edge of the die block to here, and I'll make that 1.25. And I'll place a dimension from this point to the origin of the tool, and I will make that 1.5. And then I'll place a dimension between the 2 points, 1.25, and exit the sketch. All of our lifter pins are placed into the tool, and I'll select Save. And I will now place in all of the screws and dowels that are needed. I will start out with placing screws in for this first die block. So I'll select Standard Component Library and select Socketed Cap Screw. First, I will select the screw head face, which will be at top of the die block, and then the tap plate. I will select a different size. So from the list here, I will select 3/8/16. We get a preview, And I will also adjust the depth of this counter bore so that we have some die life. So I will add a 1/4 inch to the L1 dimension in the single machining box. This will add some extra space between the top of the screw and the top of the die block, so when they sharpen the block, we have extra room. Click OK. It places us into a sketch. And I will use the LogoPress automatic pattern to place my sketch points. I will set it to 6 points with a distance of a 1/2 inch in each direction. And click OK. And exit out of the sketch. I'll place 3 screws into this end cutoff punch. So I'll select standard component library, socketed cap screw. Again, we'll use 3/8 of an inch. So I'll select the top of the die block. For the head plate, the die shoe for the tap plate, get a preview. I have to put focus back into up here for the screw head plate, and I'll add a 1/4 inch to the depth of the counter bore for this. Click OK. Puts me into a sketch. And this time I will use the LogoPress 3 position by 2 edges function. I'll change this value to 0.5, the second value to 0.5, and then I'll select this edge and then this edge, and it places a point and dimensions it. Same thing here and here. Click OK to exit out of the function, and I will adjust this dimension right here, this 1/2 inch dimension. I'll make 1.75. And we'll move it down to there. Exit out of the sketch. And those 3 socketed cap screws are placed. So I will go back into standard component library, socketed cap screw. Select the top of the form block, then the die shoe. I will not adjust the counterbore depth for this because it is a form block. Click OK. Places me into the sketch. This time I'll use automatic pattern. 4 points. Click OK, but I will adjust this dimension. Make it 1.25 inches, and same thing for this dimension. And exit the sketch. I need to also place in some socketed cap screws for the parallels. So I'll go to standard component library, select the socketed cap screw. Head plate will be the die shoe. Tap plate will be the parallel. I'll adjust the size. This time I'll select 1/2 inch 13. But as you notice, the tapped holes are already in the parallels, so I'll put focus on this tapped hole screw plate and check do not create this hole because we do not need the tapped hole. Select OK. It places me into the sketch, and I'm going to place sketch points that are in the center of each of these tapped holes. So I select the SOLIDWORKS sketch point, And then holding down the Shift key so I can select through transparency, I'll place sketch points in the middle of each tap tool. And exit the sketch. But notice the handling hole, lift hole, is right in line with the screw. So I'm going to go back into tool structure and select the punch shoe from the list here. Scroll down, and I'll change the lift hole distance to 5 inches. And that moves it out of the way. Exit out of tool structure. We can now place in our dowel pins. So I'll go into Standard Component Library, select the straight dowel pin. Press fit plate will be the die shoe. Slip fit plate will be the die block. Get a preview of our dowel pin. We will use a 3/8 diameter and click OK. Places us into the sketch, and I will use the LogoPress 3 automatic pattern. Set it to 2 points, but I will change the X dimension to 1.25 and click OK. I am going to change the value, the dimensional value here, make that 2 inches so that it's off of the parallel, and exit the sketch. I'll place a couple of parallels in this end cutoff punch, so I'll go back into Standard Component Library, select dowel pin. Press fit plate will be the die shoe, slip fit plate will be the die block. Select OK. This time, I'll use the LogoPress 3 position by 2 edges. First distance I'll leave it 1/2 inch. The second distance I'll make 1 1/4. So first selection will be the top edge, then the right hand edge, and I'll place a point. Same thing here, top of the bottom edge, right hand edge, places the second point. I can then click OK and exit the sketch. Need some dowels in the form block, so I'll go into Standard Component Library, dowel pin. Press fit plate will be the shoe, then the form block for the slip fit plate. Select OK. I'll use the position by 2 edges. First selection will be the right hand edge, then the back edge. Place a point there, and then I'll select the left hand edge and the back edge. Place a point right there. Click OK, and I will adjust this vertical dimension, and I'll make that 2 1/4. And exit the sketch. Our screws and dowels are now placed for the bottom half. Let's select Save. And let's show the upper half of the tool using our LogoPress filters. I'll first place in my socketed cap screws for the punch retainer plates. So I'll go Standard Component Library, select socketed cap screw. Screw head plate will be the top of the punch shoe. Tap plate will be the punch retainer. And we need to change the diameter to a 3/8 16. and click OK. Places this into a sketch. I'll use the LogoPress automatic pattern. I'll set it to 6 points and change it so it is a 1/2 inch in each direction. And then click OK and exit the sketch. Again, I'll go into Standard Component Library, select socketed cap screw. The head plate will be the top of the punch shoe. Then the tap plate will be the punch retainer plate. Select OK. Puts me into a sketch. I'll use the automatic pattern. This time only 4 points. 1/2 inch from each corner. Hit OK. And exit the sketch. I'll now place in the dowel pins. So I'll go Standard Component Library, straight dowel pin, press fit plate, top of the shoe, slip fit plate will be the punch retainer plate. Select OK. Again, I'll use automatic pattern. I'll use 2 points, and the X I'll change to 1.25. The Y will be a 1/2 inch. Click OK, and I'll change the offset on this value right here to 1.5 inches. Select OK, and exit the sketch. Standard Component Library, select dowel pin again. Press fit plate will be the top of the shoe. Slip fit plate will be the punch retainer plate. Select OK. Use automatic pattern. 2 points, same dimensions. Select OK. Again, I will offset this back right hand corner to 1.5 inches. Exit the sketch. We'll now place mounting screws for all 4 punches. So I'll go into Standard Component Library. I'll select socketed cap screw. Screw head plate will be the top of the punch shoe. Tap toe plate will be the punch. You get a preview. I'm going to change the size. I'll make it a 5/16 18 and select OK. Puts us into a sketch. I'll use the automatic pattern. 2 points. The X I'll make 0.375. The Y I'll make 0.3125. Click OK and exit the sketch. I'll place some screws into this next punch. Standard Component Library, socketed cap screw. Screw head plate will be the top of the punch shoe. Tap plate will be this punch. Select OK. This time, I'll use position by 2 edges. First value, change that to 0.375. Second value, 0.375. But you notice I cannot select through this transparency. So I will hold down the Shift key so I can select through. So I'll select the back edge. Then this edge places a point, back edge, and right hand edge. Same thing down here and right here. Click OK and exit the sketch. Next I'll do the form punch. So standard component library, socket of cap screw, head plate, top of the punch shoe, tap plate will be the punch. Click OK. Again, I will use position by two edges, except I will, so this time I will select this back edge and this edge, back edge and a right hand edge. Click OK. If I need to adjust these two values right here, I'll make them 3.125. I'm sorry, 0.3125 for both of these. Exit the sketch. Again, standard component library, socket cap screw, screw head plate will be the top of the punch shoe, tap plate will be the end cutoff punch. Click OK. Puts me into a sketch. This time I am going to place a construction line. And then holding down the shift key, I'll go from the midpoint of this edge to the midpoint of this edge. And then I'll place a sketch point that is coincident, two sketch points that are coincident with that construction line. And I'll place a dimension 375 from each edge. And exit the sketch. And let's select save. The last thing that we need to do is put some shedder pins or oil breaker pins into the three cutting punches. This is to break or shed the scrap from the end of the punch if it sticks. So what I'm going to do is isolate those three cutting punches so that that is all we see. I'm going to use the SOLIDWORKS isolate command to do that. So I'll select one of the punches, and then holding down the control key, I'll select the other two punches. Right click and select isolate. I will put in the shedder pins using a standard component machining axis, and then I will select a predefined favorite. Go into ejector pins, go 0.32 diameter, and select the date in progress J3. Machining axis reference face will be the top of the punch. I'll select OK. Puts me into a sketch. And I'll use the LogoPress position by two edges. First value 0.75. Second value 0.188. So first click will be this edge. Then the front edge will place a point. Then the right hand edge and the front edge again. Click OK and exit the sketch. I'll place some more into this cutting punch, so I'll go standard component library, machining axes, select my favorite, ejector pins, 0.32, date in progress J3, machine axis reference face will be the top of the cutting punch. Select OK, puts me into the sketch. Again, I will use position by two edges. First value, make 0.375. Then second value, 1.25. First selection will be this back edge. then this edge, place 1 point. I'll select this edge and then this edge, place another point. I'll select this edge and the back edge, and place that third point. Click OK and exit the sketch. Standard component library, machining axes, select our favorite, machining axis reference face will be the top of the cutoff punch. Click OK, puts us into a sketch. This time I will place a construction line from midpoint to midpoint. Place 2 sketch points that are coincident with that construction line, and then dimension them (7/8) from your outside edges. Exit sketch. And then select Exit Isolate. This will bring back the rest of the tool. I'll show the rest of the tool using this icon, display the whole tool, and show the strip again. Hide show strip assembly. I'll then save the tool, and the tool is now complete. This ends this exercise.